Welcome back, physics students. In this question, we are going to look at a momentum type of calculation. Let's say we have a rifle and it fires off a bullet. The rifle has a mass of 3 kgs and the bullet has a mass of 0.02 kgs. They also do tell us that initially the rifle is stationary, so the initial velocity will therefore be 0 of the rifle. After the bullet has been fired, the rifle moves at a velocity of 1.4 meters per second. But it shoots backwards as the bullet is fired. Therefore, we can say negative 1.4. That is, if we use to the right as positive and to the left as negative. And then they ask us to calculate the velocity of the bullet immediately after it leaves the rifle. Right, let's have a look. Now remember, we are working with the conservation of linear momentum. We have to then state that the sum of the momentum before the explosion, in this case, our equal sign will resemble our explosion, is equal to the sum of the momentum after the collision or explosion. Now remember, the formula for momentum is m delta v. Because we are starting off with 1 unit, the rifle is inside of the bullets, I'm going to keep it as one term in the beginning. After the explosion, the bullet shoots one direction and the rifle on its own in another. All right, they told us, let's go and substitute, that the rifle is initially stationary with the bullet in. So initial velocity is 0. Adding the two masses, that is how we get this bracket. On the right hand side, they gave us the mass of the rifle and we have the velocity of the rifle. Then again, the mass of the bullet, and we have to calculate the velocity of the bullet. And then it is just a little bit of algebra. The left hand side becomes 0. 3 times negative 1.5. There we go. Is this value here. Let's just put in our negative 4.2, and then we add that to our last term, which is the mass times velocity of the bullet. Right, once we take the negative 4.2 over, it becomes a positive 4.2, and then we just divide that with 0.02 to get the final velocity of the bullet after it has been fired. And because our answer is positive, we can immediately then say it is to the right.